Hello everyone. Today we are going to go through Save the Prisoner, which is a program under implementation section of algorithm on HackerRank. So without wasting time, let us have a look on the problem statement. So here's the problem statement. In this problem statement, we are supposed to share a given number of candy to a given number of prisoner. And at the end of the process of sharing, we should return the prisoner that received the last candy. So here is an example. We have 4 prisoner and 6 candy. We want to share the 6 candy to the 4 prisoners starting at position 2. You will see that we first give to the prisoner number 2, then number 3, and so on. And the last prisoner to receive the candy will be prisoner 3. So we return 3. That is the whole process. So after the process being described, you can directly think of looping through this array of number of candy, and whenever you are giving a candy to a prisoner, you move to the next prisoner. That means the prisoner plus 1. But if you are already at the end, the next prisoner is actually the prisoner number 1, and at the end of the process you return the ID of the prisoner. That is completely okay. But the issue with that approach is that it's big of n. So here we are going to try to solve it with big of 1. And to achieve this in big of 1, the first thing we can remark is that we are looping through the number of prisoner a given number of times that we can get rid of. Let's say, for instance, we have 6 here. You see, we are starting 2, 3, 4, 1, and after this we are restarting the process 2, 3, 4, 1, and so on and so on. So if you want to achieve this in big of 1, the first thing we need to do is to remove the number of repetition in the loop. And removing the number of repetition in the loop will be to take the number of candy we have to share and remove the greatest multiple of the number of prisoner in it, so that we just remain with the element that we can share without making a loop. In this one, for instance, we have 6, so we should remove 4. Then we will remain with 2. So we just need to share 2 candy, which is 2 and 3. Let's assume we are having maybe 7 here. We will still remove 4, and then we have to share 2, 3, and 4. If we're having 10, we should have removed instead 8. Then it will remain 2. That will be to 2 and 3. And we can achieve that by using the modulo operator. So we say, okay, int the element, the candy we have to share will be m modulo n. So now I have the number of candy I need to share without repetition. Perfectly okay here. Now when I'm sharing, at the end of the sharing, what is the name of the index of the prisoner will be at. So to achieve that, you can just you can have a look on the process here. You want to share 2 candy. We will share at the position at the prisoner x and the prisoner x plus 1, and so on and so on. So if we know the starting point, which is actually given, which is s, we know that at the end we will go to s minus 1. Why minus 1? Minus 1 because we are giving a candy to the first prisoner, also the prisoner where we are starting. Let's imagine we have 2 candy to share. We will give to prisoner 2 and prisoner 3. So at the end we'll be at 2 plus 2 minus 1, which is 3. 2 plus 2 minus 1, which is 3. So this is how you can compute the position of the prisoner where you will be at the end. But there's an issue with this. You can easily find yourself with an index which is greater than the number of prisoner, because when adding this, there is no insurance that it will always be less than the number of prisoner you have. So you can add a condition here. Say, okay, if the number of prisoner C is actually greater than, if the position is actually greater than the number of prisoner, then you remove the number of prisoner. That means you have to go back to the starting point. And another thing is that this one can also find itself, when you are removing this -1, you can find yourself at position 0. So, and the prisoner 0 doesn't exist. So you say, okay, if the prisoner is actually equal to 0, then A would take N, C would take N, and then here you return N. So let us run this and see what it gives. You return C. Let us run and see what it gave. I directly submit. So you have everything green. This is a nice approach of solving this big of 1. Now you may ask yourself, why do we even need to go through all this condition? And you are right, you can achieve this without going through all this condition. What can we make use of to achieve that? The first thing is that, okay, we are making this condition is because we are adding this element after the modulo operator. That is why we can find ourselves with a result which is greater than the size of the prisoner. So what you can do is that instead of that, I'll just put it here. Instead of that, what you can do is that you add it here directly. You add the S -1 here. And when adding it inside here, you don't need the second condition anymore because you are sure that this modulo operator will always be this one. You put it here. So you perform the sum first before the modulo operator. When doing so, you are sure that you don't need this condition anymore because this one will always be less than N. Now, this condition, how can we get rid of this condition? Now we can see that this condition exists only because the modulo operator will actually return element from 0 to N, and the prisoner 0 doesn't exist. So if you want to remove this condition, you can remove -1 here. By removing -1 here, you are just kind of performing a shift. That means, okay, if you are having 4 prisoners, now you are performing a shift saying that the prisoner 0 will actually refer to prisoner 1. The prisoner 1 will actually refer to prisoner 2. So the -1 will perform a shift. And by doing so, you're sure that when you have this result, if you add +1 at the end, this one will give you exactly the index of the prisoner that will receive the last candle, because you perform a shift here, and then here you append that shift that you perform here. And so here you can just directly return this. And this will give you the same result as what we have in previously. Let's just run and see what it gives. You have everything in. Let us submit. Everything green. Perfect. So this was my approach of solving this. I hope you do enjoy it. Feel free to leave me a comment in the comment section. I'll be really happy to interact with you regarding this problem. See you on the next video. Ciao.